All right, welcome to this week's episode of our show, True Data Ops. I'm your host, Kent Graziano, the Data Warrior. Each time we meet, we bring you a podcast covering all things related to data ops with the people that are making data ops what it is today. Today, my guest is Barr Moses, the co-founder and CEO of the data observability platform Monte Carlo. Welcome to the show, Barr.
Thanks. Great to be here, Kent.
So, to get started here, for folks who aren't familiar with your story, could you give us a little bit about your background in data management and how you got started in data?
Yeah, of course. My favorite topic. Good morning, everyone. Hope you're having a great day. So yeah, as you mentioned, I'm the CEO and co-founder of Monte Carlo. We started the company actually exactly 4 years ago. We're celebrating 4 years this month. Thank you. It's exciting. And, Monte Carlo really created the category that we call data observability. I'll talk a little bit more about that. But, we're fortunate to work with amazing customers like Gusto, JetBlue, Vimeo, New York Times. All data teams are on the hook to deliver data to improve their organizations and deliver better experience for their customers. Me personally, my background, I was born and raised in Israel. Actually grew up my mom was really into kind of meditation and dance. My dad is a physics professor. So I grew up reading a lot of books together with him and actually experimenting in his lab very early in my childhood, which was always fun. Later on in my career, maybe in the last sort of decade and a half, I've been really working with data in various formats in various organizations. I studied math and stats. And I think there's this big shift that, I was fortunate to be a part of in the last decade, where I think a decade ago, someone was like, oh, we're using data. It was kind of true, but kind of not really true. And I think when people say that today, there's more meat behind that, if that makes sense. So prior to Monte Carlo, I was VP operations at a company called Gainsight, which created the customer success category. Yeah. And so we use data a lot to better understand customer behavior, to predict customer churn, to understand customer upsell, customer behavior, customer adoption. That was really fun, really exciting. And I was actually responsible for the data at Gainsight that was used both by our customers and also by our executives and our board to make decisions. And so going through that, that transformation as a company, when we're really trying to become data-driven, was a lot of fun. And then, the experience that I had was that the data was wrong all the time. I would wake up every Monday morning and just wake up to a barrage of angry emails. Oh, no. And it was really frustrating. And we were trying to become data-driven, but it was incredibly hard because the data was wrong. And so that kind of led to the birth of Monte Carlo.
Wow. That's quite a journey. Yeah. So you took your, I'll say, the pain from your then current job and said, how can we solve this, right? And then came up with this idea for Monte Carlo. So the category there from Monte Carlo is talking about the data observability. And how do you see that fitting in with data ops and the way people are doing business today? Is it really, I think obviously the answer to this question is it required for organizations to be successful? Pretty sure your answer is yes. So how does this all fit together, and why do you think it's so important?
Yeah, great question. And I'll tell a little bit more about the founding story, because I think that helps explain some of your questions around, is it important for data organizations? So I think we certainly started with my experience, right? So I was responsible for the data. The data was wrong often. And we were often the last people to know about it as data teams, which was really how is it that we had one job, get the data right? And yet we were the last people to find out about it. And that was extremely frustrating. And then when we had to resolve it, I remember we would get together with Will Robbins, who I worked with at the time and is still at Monte Carlo now. I have the pleasure of working with him. We would get into, a room with a whiteboard. And we basically try to map out the lineage of where data starts and how it ends in a report, and basically manually track how the data moves from stage to stage. It's funny, I share this story with someone And he was like, yeah, I used to take like screenshots with my iPhone to make sure that the data is accurate. Yeah, I was like, that's a whole new level. I didn't even think about that. So there are just incredibly manual ways of making sure the data is accurate, which obviously, are not scalable, but also just doesn't make sense for an organization to pursue every time that there's a data issue. And I wasn't sure if that was something that was really sort of just something that, Will and I were experiencing, or if this is something broader. And so I actually ended up speaking with about several hundred actually of like data leaders, folks who chief data officers, VP engineers, data engineering, folks sort of from various industries, sizes of companies. And this problem that we later called data downtime, periods of time when data is wrong or inaccurate or otherwise erroneous, came up again and again. And it was true for literally every industry, every size of stage of company. Like the number one thing that folks said was, hey, the data is wrong. And that actually leads us to a place where we can't trust it or can't use it. And so, I think the first important thing to recognize is that the problem of data trust is something that's ubiquitous, and then is also getting worse over time, right? This was when we start, when we looked at this is, or when I was doing this at Gainsight, this was 2016. Today you have way more people using data, way more products that are based on data. The implications of the data being wrong are way more severe. Like I remember in 2016, one of the big issues that happened with bad data was that Netflix was down for 45 minutes because of duplicate data. Netflix being down is a big deal, Ken. 45 minutes is a long time. Right? I don't know how I would survive without that. But, today, actually just a couple of months ago, Unity, for example, published that one data issue that they had cost them $100 million.
Wow.
Yes. And Equifax actually shared that they issued credit scores that were wrong. Millions of users because of bad data, right? Those are like people's lives are impacted.
Right. Yeah, that can affect your ability to get a mortgage or even a car loan, or maybe even get approved for a student loan if your credit rating's off.
Exactly. Yeah. And so the implications of bad data are hitting not just organizations, but individual like you and I, right? And so I don't think we can afford to kind of ignore that problem. And this is where, data observability comes to help. And so, you asked, how does data observability fit within DataOps? I think this movement of DataOps, which, I largely think of as, using some of the best practices that we know and love from DevOps and SecOps, right, and then implementing in them DataOps, right? That is exactly sort of at the foundation of what we believe is data observability. Data observability builds on concepts from observability and software engineering. So you would never think to have an engineering team that doesn't have something that helps you make sure that the infrastructure and applications that you're building are reliable, right? Like the website that you're building or whatever it is, making sure that that's reliable. How are data teams being able to afford, being blind, flying blind, and not knowing when data is inaccurate?
Right. Or what the state of the data is. I mean, I've been in the data warehousing world for over 30 years, and there was always those questions of how fresh is the data, right? Back when we were doing just purely batch processing. And the question was like, well, when was the last time the data was updated? Because it looks like it's wrong, but it might technically not be wrong if it hadn't been updated for like a week, right? That's actually last week's data. That's not this week's data. And other than looking at the logs from the ETL jobs at the time, you had no way to do it. And I remember working with teams where we built basically dashboards for the metadata from the ETL tool, so that the business people could go in themselves and go, when was the last time my data was updated? And heaven forbid they went in and saw that it was like a week ago and it's supposed to be refreshed every 24 hours. And then again, the data team gets the calls like, guys, you realize that your process didn't run last night? That my data is way stale and this is just like no good to me at all.
Yep.
And that was back, the first data warehouse I did, I wrote all the code myself, and it was just me, and it was all SQL. So the load processes it was Oracle. So it was SQL loader and then some SQL insert scripts and views that built it. But we didn't even have, I don't think we had even a batch engine is like I forget how we even got it to run manually. So if something went wrong,
Wow.
I pretty much knew the whole thing because it wasn't that big, right? It was,
Yeah.
it was really small. It was like a once
You were
a month.
manually running it every night is basically what it sounds like.
Yeah. I eventually got figured out how to write a batch script. It was
Okay.
DOS, right, to make it run. But it was once a month we got an extract from the finance, which was COBOL, right? So you got a flat file once a month, and then I had to run it, load it in, and then run another set of routines to do the aggregations because they, of course, wanted weekly, quarterly, semi-annual, and annual, and you had to keep updating the stuff. But I was a one-man show, and so if something broke, I could pretty well guess where it broke because I wrote it all. But as you said, that doesn't scale. Today we're looking at what? We're looking at hundreds of terabytes, petabytes of data. We're looking at batch data. We're looking at streaming data and things that are really important, like healthcare data coming from IoT devices in hospitals. I mean, this stuff can't be wrong, right? So how do we operationalize that, right? That's data ops, data operations. How do we operationalize that in a way that makes it effective? And we get the notifications, right? But
totally,
you can't get notified if you don't know what's going on, right? So that's where the data observability comes in, right? What happened?
Exactly. And I think your example is so perfect because it speaks both to the problem and I think the solution. So, you described, once a month, you would load a file from finance and probably like you then had like another month or so to like make sure that the data is accurate because there's just more time. And it would, you said you were a one-man show. There's probably a couple people using the data. But the thing that's changing today is like, not only do you have a lot more data, you have also a lot more people using the data and you have a lot less time. Like you don't have, the financial data might be coming multiple times per day and might change throughout the day, right? And then you might have sometimes hundreds or thousands of people using that data. Maybe the marketing team is using it for marketing campaigns. Or maybe the product team is using that, by surfacing some of those reports directly to your customers, right? We have customers who send weekly and now daily reports to their customers. So that's like, the problem is only exacerbated. And then I think the solution also, you mentioned like, okay, you knew everything. So you knew if like, the job wasn't completed or if something was late. But the thing is now, so many people rely on other teams. They often don't know when the data is late. So they don't even know kind of what to specify or what to test for. And so, actually we had this challenge when we started the company, which is what does data observability actually mean? Like, what are you actually looking for? And the definition is understanding the health of a system based on its outputs. So we actually defined 5 pillars that we kind of, based on speaking with hundreds of folks, Ken, you probably could write the book on this, to understand what are all the reasons for why data goes wrong. And you mentioned the most common one, or one of the top common one, which is, the data is late. And so that's the first pillar. That's basically freshness. And so imagine that instead of like having to specify for every single job that you're running, making sure that it's running on time, having an automated way to make sure that if there's any job that's late, or out of a historical pattern, you would be notified, right? So folks have hundreds of thousands in tables oftentimes. And, if a table is supposed to get populated at 8 a.m. and it's 8:15, someone needs to know automatically. And people don't have like hundreds of thousands of Kents to like define all the different table times, right? So freshness is a really big deal. The second that's a big deal is volume. So maybe the job was completed, but there's no data, right? There's like, instead of like 100,000 rows, there's like 3 rows that were passed over, right?
But you have to know how many rows should there be, right?
Exactly. And that again, doing that automatically too, right? Yeah. So volume is the second pillar. The third pillar is schema. So actually schema changes, and by that I mean like, a field being removed, a table being removed, a field being changed in type. Those are like the secret, there's like the culprits of all like evil in the world, I think. I'm kidding. But
for a data team, whether it was data warehousing or building data marts, that was certainly the bane of my existence, about a decade ago, with the source system changed and didn't tell anybody. And then a whole bunch of stuff falls over because one column, they changed the data type, or like I said, they dropped a column. It's gone.
I don't know. Never happened to me, Kent. I don't know what you're talking about. Not to me. Yeah, you're exactly right. Right. And you're not aware of those. And, people go on about the course of their business and, we also want to move fast as teams. And so we need to make changes. So schema changes is another big one. And then the fourth is actually the quality itself of the data. So for example, you might have some percentage of nulls and then like it's a way higher than before, or, you might have a particular value that you expect, like, I don't know, something numbers between, like for a credit score, if you suddenly have the number like 2000, okay, something doesn't make sense.
That's definitely wrong there.
Exactly. Or I don't know, maybe something really good, but in those instances, actually automating that by looking at historical patterns and being able to say like, hey, the number here has never been higher than 800 or whatever it is. And so it should be flagged. And then the fifth pillar is lineage. So both table and column level lineage. Yeah, exactly. And I'm thinking about the days when I had to like manually map it on the whiteboard.
Right.
Now we can actually automatically reconstruct that both across systems. So it could be like across, a data warehouse and a BI solution, help you understand all the dependencies. And when something is wrong, you can say, oh, well, my friend Joe and Jane are going to be impacted by this. So I better give them a call and tell them that the schema change that I made is going to interrupt their course of operations, or even send an automatic alert to them. And also when there's an issue, I can understand what are the upstream root causes. So like, what is that job upstream that failed and why? And what are some correlated events that can help me understand what's going wrong? And so those 5 pillars in an automated way is a very kind of, revolutionary way to think about data quality, data trust, data health in a way that wasn't possible before.
Yeah, and that plays into the whole philosophy and the pillars of true data ops. I mean, one of the key pillars is the automation piece, right? And that's, we can't, like you said, you can't have 1,000 data engineers like me sitting around manually checking all this stuff.
I wish we could. Ken, tell me how to make it happen.
Yeah. Well, it wouldn't be, you couldn't afford it. Just trust me. You couldn't afford it. You have to automate it, right? The only option in order to meet the needs at this kind of scale is automation. And, again, automating the operations and all of these things that we need to keep track of, the lineage. Figuring out the lineage. Like I said, I knew the SQL statements and I knew which order they ran in because I wrote the batch script that they run. Notice goes this, you got to do this one first and this one and this one and this one. So I know what happened to the data, but nobody outside of my office, I shared with one other person, had any idea what the process was. They would show up. You're going to love this. I don't know how far, if you go back far enough to remember Power Builder. There was one guy who built what we had for a dashboard was a hard-coded Power Builder app with hard-coded drills to go to the different aggregations that I had built. And so he knew where the data was. And then we had one person who used that app, right?
Well, yeah.
But nobody else had any idea. How did the data get to that app, let alone what were those numbers made up of?
And what kind of
math did I do to make those numbers show up? So yeah, having all of that in, be metadata driven and being able to visualize that today, that's stuff that we've needed for, really literally decades. And now we're at the point with the cloud and technology has evolved to the point that we can now build tools like Monte Carlo to help with these sorts of things. So I want to move on to what's probably like one of the hottest topics going on in data today, data mesh. So how do you see observability playing in this data mesh world of distributed, decentralized, federated data environments?
Yeah, great question. And, I think data mesh is definitely like a hot topic, a buzzword, just like up and downs, that the term has gone through. I think, regardless of like the buzziness of the term, I'm seeing companies adopt data mesh to various degrees, even if they don't actually call it data mesh. And actually, one of the people who I think has some of the most interesting stories about this is Shane Murray. He was the SVP data at the New York Times. He's written a lot about this. And actually, they have a data team of about several hundred people. and a very federated model. So I think, the New York Times is a good example of someone who's like implemented, one of the most advanced data mesh implementations that I've seen. But quite frankly, there are not very many organizations out there who have fully adopted it, right? I'm sure you see it. I mean, some other customers that we work with who are strong champions, like Roche, for example.
Yes. They're the poster child, really. Yes. They really are.
Exactly. Clear cover as well. And I think, to your point, there's some, kind of, I would say, standards or fundamentals of data mesh. One of them is like federated governance. The second is domain ownership. The third is sort of thinking about data as a product. All those concepts tie into what we just spoke about, right? So when you're thinking about data as a product, that means that you probably have like different teams using different products. You might even have self-serve analytics or self-serve data, a world where consumers are using data and not talking to the Kents of the world or the people running the data platform. And so they need to make educated decisions on which reports do I use, which data set is it right? Is it ARR v6 or is it ARR v5? Please use this dashboard. It's the best ever, right? Like that's literally the decision making that you're going through.
Yes.
And how do you know that that report is actually up to date with the accurate data? And so a big concept in data mesh is sort of the idea of having different domains. And by domain, I just basically mean like different teams. So, in your example, it could be like the financial team. We talked about marketing team use it. Then you talk about marketing team, basically different. And it could also be by business unit, right? But basically being very specific about which data sets are owned by different teams, which data products. I think this is more interesting to use the data product lens.
Yes.
And then, if you have lineage, you can actually like understand what are all the upstream dependencies of that data product. And for the particular team that owns that, making sure that the data is healthy, not only, when it is consumed, but all the way before. So from ingestion to consumption, because data can change anywhere along that step, right? Oftentimes there could be like hundreds of tables that depend each other. We talked about someone like making a change to a column somewhere, dropping a column. That can happen anywhere along. It could be like hundreds of steps. And so having that view becomes even more important when it's a federated model, when it's self-service, when there's a large number of people who are using data. So for me, I think data mesh is kind of going to the data ops movement. I think it's kind of under that umbrella, if you will, if I call, right? Like data mesh sort of comes from, again, best practices in software engineering. And so I think sort of an evolution in data that's natural. On the buzziness of the topic, I probably can't comment anymore.
Yeah. Now you mentioned some of these interesting, and this came up when I was working at Snowflake with the data marketplace. We used to get questions all the time. It's like, how do I know that data that I'm getting off of the market, that shared data set, is actually good? Right? What's the data quality? How do I have access to that? And that's something that is, evolving. It's like, you've got to have some data quality metrics. You've got to have this kind of observability. And for the data product team, you said something here that I hadn't really thought of before. There's a very interesting problem, whether it's just data products or data mesh, is if you've built a data product, you need to be very aware of how it's used downstream from you. Right? And when we think in the data warehousing world, we used to think about lineage. We're looking at a report, and we want to trace it back and see what happened, along the way. But here, my role ends here. I've created the data product, but we've made it available on the Snowflake marketplace. And
that's right.
Hundreds of companies, thousands potentially, are maybe consuming it now. As we have to be aware of where did that data go, and what we do here. If we want to evolve the product, and we're going to do a new version of the product, how many people downstream is that going to affect? And making sure that we've got that backward compatibility, right? That we don't break anything, because we can't see anything. It's like, here's my data product, here's downstream consumers. I can't see this over here because it's secured, right? I can't see what they've built and what they're doing with the data, but I know they're consuming the data. If I change something here in my product, I could potentially break thousands of applications all over the globe by making one little change and not doing it in a proper way. So having that forward-looking lineage, that's an interesting concept, right? Is to do that. Well, we used to call that impact analysis is probably what we called it, right?
That's exactly right.
How do you do that? And that's really, really important to be able to do that sort of thing these days.
Yeah. Data teams have a lot of power these days. Like what we do matters as data teams. It's no joke. No pressure.
No pressure. Yeah. So what do you think is the biggest hurdle facing data teams today?
Great question. So I think, well, I always think of this story. I think a couple of years ago, someone woke up and said, hey, let's get data driven. How cool would that be? And basically everyone rushed to become data driven. And that meant like we hired a ton of data engineers, data scientists, data analysts. We invested a ton in data infrastructure, and we have like, the best infrastructure, the best teams. Now it's money time. Like we got to prove that was worth it, right? We got to prove we can actually draw insights. We can actually use that data. We can improve customer experience. We can build better data products. That's not easy. I think we're up for the challenge as data teams. I think it's a very exciting time to do that. And I do think, by the way, that like being able to trust the data, I know I'm biased, but being able to trust the data is one of the main reasons why people don't adopt the data. They just end up saying, hey, this is wrong. So like, I'll just resort to my gut. But I think for data teams, being able to, really sort of prove ROI and actually like say, hey, we've invested all of this and here's like the great benefits for our customers and for our outcomes, is something that's I'm really, really excited that data teams are able to do more and more of today.
Yeah. We've got to be able to show the actual business value. This takes me way back to my early days doing Agile and the idea of a prioritized backlist. Well, how did you come up with a prioritized backlist? You have to talk to the business and say, of all the things we could be doing with the data, what's the most important to the business? But then, the business says, let's do this. We need this data. This would make a huge difference. But like you said, then the next challenge is, well, are we actually measuring that result and seeing, was that the right investment? Was that the right decision? Should we do more of that? Or should we do less of that in order to actually deliver? Are we really delivering value to the business? And that's a hard thing for data people.
100%. Totally. And I think you're spot on. I think the teams that do this well, they do a couple of things. One is they actually understand what data matters to who and why. Like, I'm not sure that's actually obvious to everyone, kind of talking about like, hey, we're delivering something and then my job is done and I don't know what's happening with it. Actually, I think strong data teams understand when this data breaks, this person cares about it and this team is going to use it. And this is tied to ad revenue. And this is tied to our personalization engine, right? Having a strong understanding of what data matters. I think the second thing that strong data teams do is they actually tie themselves to important company initiatives. Like maybe it's a new product launch or a new monetization effort or a better customer experience delivered. Data teams can actually tie, hey, we're working on this and it's going to improve this. And then the third thing that I think people do, to your point, is they actually are able to measure themselves, whether that's with like, improved SLAs or time to detection, time to resolution of incidents, or better yet, to your point, getting closer to the business, actually like helping the marketing team with like a great win or helping the product team launch something new. Like I think those being able to measure and showcase those wins can go a long way for the data team.
Yeah. And I think that's where these concepts of data ops and data observability play into this. It's like, we have to be doing that in order for all of those things to be manageable.
Oh,
right?
yeah.
To be actually pull it off, right?
Yep.
And to empower the data team. And I think that's one of the concepts in data mesh that I like is the idea of the domain team being it's the people who understand the data are taking responsibility for that data. And that gets us a long way towards the ability to make sure that we're delivering value from the data. Like you said, they understand the data, they understand how the data could be used, and hopefully understand how the data is being used.
100%.
And all these tools help. So got to wrap up now. So I wanted to ask you a couple of things. Are you speaking at anything in the near future? Any upcoming events or conferences or webinars or things that people should be looking out for to hear from you?
Yeah, actually, we have a fireside chat coming up with our customer JetBlue about how they use Snowflake and Monte Carlo, which is exciting. We released an O'Reilly book not too long ago about data quality and fundamentals of data quality. And we actually write a lot on LinkedIn in our blog post. I just wrote about the next big crisis for data teams. So encourage folks to check that out if they'd like.
Okay, and so the best way for folks to follow you so that they see these things as they're coming up.
Yeah, so welcome to follow me on LinkedIn, or you can email me directly, barr@montecarlodata.com. Feel free to reach out. Yeah, our blog is montecarlodata.com. The kind of main blog is where we publish all of our thoughts.
Okay, excellent, good. Yeah, people always want to be able to follow folks after they hear from them. So, well, thanks. I know we got to go. Thanks for being my guest today, Barr, and thanks to everyone else who's joined and watching or watching on the replay. Next time, I'll be coming live from the Worldwide Data Vault Consortium in Stowe, Vermont, and my guest there will be Neil Strange, who's the CEO and founder of Data Vault, a UK consultancy. So don't forget to like and repost or retweet the replays and tell all your friends about the True Data Ops podcast. And if you've not already done so, go online to truedataops.org and register for this podcast so you don't miss any future episodes. So until next time, this is Kent Graziano, the Data Warrior, signing off. Have a great week.